This video is about graphing and summarizing data. There are two descriptive data forms. One form of descriptive data is a numerical summary, which is a snapshot of a data set that we commonly see as a data table. The other descriptive data is visual, which we frequently see as a bar graph or pie chart. A data set is a collection of many numbers, and just one of its values is a data point. The size of a data set, denoted by capital N, is the total number of all the single data points in the data set. The size of this data set is equal to 13. The data sets that we will be looking at either have quantitative or qualitative variables. Variables are data points or any other characteristic that vary with the members of the set. Some variables can be numbers, colors, gender, enrollment, salaries, or anything else that changes with the data set. The variable that we will look at in Table 14-1 are the test scores of students in a make-believe Stat 101 class. Each test score varies with each student. This type of variable is known as a numerical variable or quantitative variable because it represents a measurable quantity. There are two types of quantitative variables. One is a discrete variable and the other is a continuous variable. Discrete variables change by discrete increments. The Stat 101 test scores are known as discrete variables because each score is an integer. Some other examples of discrete variables are items for sale because they are sold by certain increments. Another example is shoe size. Shoe sizes are measured in whole or half sizes. Continuous variables can be measured continuously or by arbitrarily small increments. Examples of a continuous variable are the volume of water in a glass and a person's height, weight, and age. You might be asking yourself, but wait a minute, aren't a person's height, weight, and age discrete variables? Well, yes, they can be. We often blur continuous and discrete variables together by rounding continuous variables into discrete variables. Although we have continuously grown from when we were born to adulthood, we round our height to the next closest inch, our age to our previous birthday, and our weight to the next lowest pound, or 10 pounds in my case. Categorical variables, or qualitative variables, are variables that cannot be measured numerically, but rather are given a characteristic value we assign it. Some examples of categorical variables are gender, colors, clothing brands, street names, and more. Qualitative variables do not follow the field properties of addition, subtraction, multiplication, and division, but they can be treated like a discrete numerical variable because we can count how often they occur. We can find the size of the data set in Table 14-1 by counting the number of students who took the test. There are 15 rows and 5 columns in this table. We can find the product of these values to find the size of our data set, which is n is equal to 75. This table doesn't tell us much information by just looking at it, but we can reconfigure it to make more sense. We can make a frequency table that will summarize the data by showing how many times each score appeared. Making a frequency table can be very tedious if we're working with very large sets of data. Let's say 1,000. You and I don't want to count any data set of that size. We would resort to a computer to do most of the counting for us if that were the case. We are fortunate to be working with a data set of 75, which seems feasible enough. Starting at the beginning, let's count the students who scored a 12 on this make-believe exam. 1, 2, 3, 4, 5, 6, 7, 8, 9. I see no more students who scored a 12 on the exam. We now know the frequency of those who scored a 12 on the exam is 9. We repeat this process for the rest of the scores to find the frequency of each score and place them into our frequency table. For time's sake, I will skip counting the rest of the scores and go straight to our frequency table. I know you are cheering on the inside, so let's move on. We can use the frequency table to transform the descriptive data from a numerical summary into an eye-catching visual. Figure 14-1 is a bar graph of our frequency table, which displays the scores along the x-axis and the frequency of each score along the y-axis. The height of each bar is the frequency of each score. Do you see the two bars that do not conform with the others in the bar graph? These data points are known as outliers. In this bar graph, our outliers are 1 and 24. Outliers are sometimes excluded from the data set. Another graph that is very similar to a bar graph is the relative frequency bar graph, which shows the height of the bar as a percent of the total population. Here we can compare a bar graph and a relative frequency bar graph to see how similar they are. If we again look at those who scored a 12 on the exam, we find the relative frequency by substituting our values into this equation. The frequency of those who scored a 12 on the exam was 9. We divide this by the total population, which is 75, and we get a relative frequency of 0.12, or 12%. As we can see in the relative frequency bar graph, this is what is shown. If we wanted to make our graphs more interesting, we could turn our bar graphs into pictographs, which use images and icons instead of a bar. In this video, we have shown you a method that allows you to turn data into a visual. When data is in a visual form, we can make quick conclusions about it. Looking at the bar graph, we can see that a majority of students scored around half the points allowed. The outliers show that one person studied very hard, while another person didn't study at all. This would be very challenging to understand if we were to look at the numerical data alone.